G'day, g'day. Today's lesson is going to be on binomial expansions involving surds. But before we do binomials, or should I say, before we start looking at these babies down here, let's do just a more simple one. Now, the thing with these is that you need to hark back to your early algebra really and decide, well, what's a term? Because when you do these, you do the term that's on next to the brackets multiplied by every term inside the brackets. So I'm going to use highlighters here just to kind of highlight what are the terms that we're dealing with. On the outside, we've got 2 root 11. Now the temptation is to say, well, root 11 is the term there, and that 2 just sits on the outside. But we realize that that's 2 lots of root 11. So that entire thing is a term. Just like 3 root 11 on the inside here is a term. Just like negative 5 root 2 is a term. And so what we have to do is we have to multiply 2 root 11 by 3 root 11. I'll just use an arrow to show. And 2 root 11 by minus 5 root 2. So what does that end up being? Well, in this case we do numbers times numbers. 2 times 3, which is 6. Root 11 times root 11, which is root 11 squared. Some of you are going, I know what that is. And then we have 2 times minus 5, which is minus 10. And root 11 times root 2, which is root 22. So we end up with 6 times root 11 squared, which is 11, minus 10 root 22. And we say, well, can we divide any square numbers into root 22? We say 4, no, 9, no, 16, no, and so that's a surd unto itself. We can't simplify any further. We end up with 66 minus 10 root 22. Nice and easy. So remember that the coefficient is part of the term. And so same thing here. We've got root 7, that's one term. 3 root 2, that's another term. Positive root 5 and minus root 3. Now these ones hark back. These are binomial expansions, and so these hark back. My way of doing these is crab claw. So that times that, that times that, that times that, that times that. Some of you might use foil, some of you just might use a picture, but I like crab claw because I can do it's like snappy crab, yeah. So root 7, that equals root 7 times 2 root 3 equals 2 root 14. Now I'm doing this quite quickly. Root 7 times minus root 3 equals minus root 21. Positive root 5 times 3 root 2 is positive 3 root 10. And positive root 5 times minus root 3 is minus root 15. So is there any that we can simplify here? 4 doesn't divide into any of these. Does 9 divide into any of these? No, 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 no. And so, therefore, we cannot simplify that any further. Let's have a look down here for the last one. Again, I'm going to highlight the terms. We've got 3, we've got root 5, we've got minus 2 root 10, and we've got minus 3 root 2. And so, crab claw, that times that, that times that, that times that, that times that. Still see the crab claw? Ha ha ha. That equals 3 times root 5 is 3 root 5. And then we have 3 times minus 3 root 2, which is minus 9 root 2. And then we have minus 2 root 10 times root 5 is minus 2 root 50. Straight away, some of you guys just went, ooh, I hope. And then we have minus 2 root 10 times minus 3 root 2. positive negative 2 times negative 3, which is positive 6. Root 10 times root 2 is root 20. Now some of you guys go, oh, well that's done. Well, is it now? Because all of a sudden we see these suckers can be simplified. Why? Because this is root 25 times 2, and this is root 4 times 5. So these can actually be simplified. These puppy dogs here can be simplified. So 3 root 5 minus 9 root 2 minus 2 times 5, because root 25, root 2 plus 6 times 2 root 5. We end up with 3 root 5 minus 9 root 2 minus 10 root 2 plus 12 root 5. A lot of rewriting there. Some of you guys might miss out steps, but don't go too hard missing out the steps, because it's easy to make a mistake, a very silly mistake here. And now we collect the like surds. Here we have a root 5, here we have root 5s. So 3 root 5 plus 12 root 5 ends up being 15 root 5. And minus 9 root 2 minus another 10 root 2 is minus 19 root 2. I hope that helped.